Hello friends, I welcome you all on my YouTube channel Science Setu. So friends, in this video we are going to discuss previous year questions of coordination chemistry which was asked in CSIR NET December 2016 exam. Okay, so let's start. Now see, this is your first question and it says, in the hydrolysis of this complex which is trans, if the leaving group is chloride, the formation of cis product is the least when A is, and you have four options. Okay friends, so in this question they give you a condition of hydrolysis of this trans complex, and in this complex the substitution the substituted ligand is chlorine or chloride ion. Okay, so now in this question you must find that the formation of cis product is least when this A is out of these four options. Okay, and this question is coming for 2 marks, that means it is related to your part B. Understand? Okay, so let's do the solution of this question. Now friends, in this question, this reaction is a hydrolysis of this compound in which substitution of chlorine occurs. Okay, substitution of chlorine occurs. Now when you carefully observe this type of reactions in coordination chemistry, that so we know that this is nothing but an example of a substitution reaction, or typically it is an example of substitution reaction in octahedral complexes. Okay, so this is an example of substitution reaction in octahedral complex. Understand? Now we know that when we study the substitution reaction in octahedral complex, there is a fixed mechanism for completing this reaction, okay, and we know very well that in the mechanism of the substitution reaction in octahedral complex, there is a formation of intermediate occurs. Okay, so in mechanism we know that there is a formation of intermediate occurs. Okay, and this intermediate is pentacoordinated complex. This intermediate is pentacoordinated complex. This intermediate is pentacoordinated complex. Okay, now when you talk about the geometry of this intermediate, so in pentacoordinated complexes we have two choices of the geometry, that is either it will adopt a trigonal bipyramidal geometry or it will adopt a square pyramidal geometry. Understand? So when you talk about the geometry of this pentacoordinated complex, so it can adopt trigonal bipyramidal or square planar geometry. Understand? Now what condition decides the geometry of this intermediate? Okay, so the first condition which decides the geometry of intermediate, that is the nature of ligand present in the intermediate. Okay, so the condition says, listen carefully, the condition says that when a pi donor ligand present in an intermediate, then it will adopt trigonal bipyramidal geometry because it stabilizes their trigonal bipyramidal geometry. So this is the first condition which decides that either this intermediate adopt trigonal bipyramidal geometry or square pyramidal geometries. Okay, so when an intermediate having pi donor ligand, that means it adopt trigonal bipyramidal geometry because it stabilizes the trigonal bipyramidal geometry. Okay, so when pi donor ligand present in intermediate, then it will adopt TBP, that is trigonal bipyramidal geometry. Okay, because this stabilizes the trigonal bipyramidal geometry. Now friends, in this question they will ask you that the formation of cis product is least when A is. Okay, so now friends, first of all, in this condition we have we have possibility of two products when this intermediate adopt trigonal bipyramidal geometry. There is a equal possibility of formation of cis and trans product. Okay, why equal possibility of formation of cis and trans product? See that remember, this is a trigonal bipyramidal geometry. Okay, this is a trigonal bipyramidal geometry. So there is a equal chances of attacking species that the attacking species attack either this side, this is called front side, or it will attack on backs this side. Okay, understand? Okay, so when intermediate adopt this TBP geometry, so in this TBP geometry there is a equal chances for your attacking species that either it will attack on front side of this trigonal bipyramidal intermediate, or it will attack on back side of this trigonal bipyramidal intermediates. Okay, so in this condition we have we obtain a product is 1:1 ratio, that is 1 is for cis product and 1 is for trans product. Okay, so we have equal possibility of obtaining cis and trans product in trigonal bipyramidal geometry, and trigonal bipyramidal geometry adopt when this pentagonal intermediate has a pi donor ligand. Okay, so for solution, so for answering this question, you must first find that what ligands are pi donor ligands. Okay, so when you carefully observe this question, see the options. In these four options there are three options, that is option number 2nd, 3rd and 4 options. So these ligands are pi donor ligands. Okay, so NCS minus, Cl minus and OH minus are pi donor ligands. Okay, pi donor ligands. So when these ligands are present in this intermediate, that means this intermediate adopts this geometry, and in the case of these ligands there is a equal chance of obtaining cis and trans product. Okay, but in this question they will ask you about that cis product is the least when A is, cis product is least. So that means when intermediate adopts square pyramidal geometry, then this means in this condition there is only a possibility of product is trans. Okay, so when intermediate adopt square pyramidal geometry, trans product obtained preferentially, but in the case of trigonal bipyramidal geometry, cis and trans products are equally possible. Understand? Okay, so that means when NO2 minus, because NO2 minus is not a pi donor ligand, so in the presence of NO2 minus ligand it will adopt square planar geometry. NO2 minus square planar geometry. Okay, it will adopt intermediate adopt square planar geometry, and in this case it leads to the formation of trans product preferentially. Okay, so it leads to the formation of trans product preferentially, not cis. So now according to this whole conclusion, we say that your option first is the correct answer for this question, that is A must be NO2 minus. Understand? See once again. So that means in the substitution reaction, you first check that the ligand will be pi donor or not. When it is pi donor, that means the intermediate will adopt trigonal bipyramidal geometry, and in this case there is a equal possibility of cis and trans product obtained. Okay, but when it is not a pi donor ligand, then in this case it will adopt square planar geometry, and in square planar geometry trans product obtained preferentially. Understand? Okay. Now we move towards our next question, and see, it says this transition from 4A2G to 2EG, the transition in the electronic spectrum of this chromium complex occurs nearly at, and we have 4 options. Okay, so we have this transition for chromium 3 plus complex, and you must find its frequency. Okay, nearly at out of these 4 options. And this question is also coming for 2 marks. That means this is also related to your part B. Okay, so let's do the solution of this question. Now this complex is given octahedral complex of chromium 3 plus. Now chromium present in 3 plus oxidation state, and for chromium 3 plus its electronic configuration is 3d3. Okay, so this is a 3d3 system, and the given transition is from higher T2 4A2G to lower EG. Okay, so this is a spin forbidden transition which is observed in the case of 3d3 condition. And we previously discussed that this is a phosphorescence. This is a phosphorescence which is shown in the case of 3D3 system. So this is a transition related to a phosphorescence, and we know very well that phosphorescence shows nearly at 6000, sorry, not 6000, 650 nanometer. Okay, so it shows nearly at 650 nanometer. So your option number first is the right answer for this question. Okay, directly solve. You may know this value 650 nanometer for phosphorescence. Okay, understand? Okay, so now we move towards our next question, and see, it says the Nephiliastic parameter beta is highest for, and you have 4 options. Okay, and this question is coming for 2 marks. That means this is also related to your part B. So let's do the solution of this question. Here they ask you about the highest value, highest beta value for which ligand. Okay, that is known as Nephiliastic parameter. So what factor decides the Nephiliastic parameter? The factor is the polarizability of ligand. Okay, so a ligand with high polarizability will have high Nephiliastic parameter or high Nephiliastic effect. This is a general concept for obtaining a value of beta. Okay, so a ligand with high polarizability will have high Nephiliastic effect. Okay, and we have a series of ligands for decreasing its polarizability. On the basis of decreasing its the polarizability of ligands, we have a series which is known as the Nephiliastic series. Okay, So according to this series, we have a ligands, that is the highest polarizability is for fluorine ligand, and after that H2, then NH3, then ethylene diamine, then NCS negative, then Cl negative, then Cn minus, then Br minus. Okay, this is a value of polarizability, decreasing order of polarizability. So the highest value of polarizability will be for F minus, that means it is having highest value of Nephiliastic parameter, that is beta. Okay, so out of these four options, the option number 4 is the correct answer, that contains F minus. Okay, and this question they may also ask about the highest value of beta, and it will depends on the polarizability. So the highest polarizability is for F minus, so it will show highest value of beta. Understand? Okay, so option number 4 is the correct answer. Okay, so now we move towards our next question, and see, it says consider the following statements for this complex ion, and we have four statements, that is it is paramagnetic, it has tetrahedral symmetry, adopts distorted square panel geometry, shows approximately D to D symmetry, and we must find that what statements are correct out, and on the basis of correct statement you must choose the correct option out of these four options. Okay, and this question is coming for 4 marks, that means it is related to your part C. So now let's do the solution of this question. So this complex of iron is given, and in this complex iron present in 4 plus oxidation state, and iron 4 plus means it is a 3d4 complex, and oxygen is a weak field ligand, so it is nothing but 3d4 high spin complex, and electronic configuration of this 3d4 high spin complex is T2G3 Eg1, or you can say this is a splitting pattern for d orbitals in this 3d4 high spin complex, that is T2G3 Eg1. Okay, so now it has 4 unpaired electrons, because 3d4 high spin means it has 4 unpaired electrons, and when any complex having unpaired electrons, that means it is paramagnetic in nature. This complex is paramagnetic in nature. So statement A is correct statement. Okay, now here is another factor which decides its geometry, or this factor is John-Taylor distortion. You know friends that in John-Taylor distortion, when T2G or Eg orbitals are unsymmetrically filled, then there is a John-Taylor distortion in the geometry of the complex. Okay, and in this complex you clearly see that the Eg orbitals are unsymmetrically filled. Okay, so in this complex John-Taylor distortion are present. John-Taylor distortion present in the geometry of this complex, and because of this John-Taylor distortion, it shows the distortion from its ideal tetrahedral geometry. Okay, so it shows this distortion from its ideal tetrahedral geometry, and it will adopt a distorted geometry, or you can say a flattened structure, and it shows distortion from its ideal tetrahedral geometry towards a flattened structure, towards a flattened structure. Okay, that means its structure is nearly a flat, not ideal tetrahedral but flat, because of John-Taylor distortion. Okay, and the point group of this flattened structure will be D2D. Okay, so it shows D2D symmetry. D2D symmetry. Okay. So now it is paramagnetic. That is option A is a correct statement, or statement A is correct, and it is D2D symmetry. That means statement D is correct statement. Statement B and C are incorrect. That means it has tetrahedral geometry, because due to John-Taylor distortion, it shows distortion in its ideal tetrahedral geometry. Okay, so that means option B is incorrect and adopts distorted square planar geometry, but it adopts a flattened structure, not distorted square planar. Okay, so on the basis of this conclusion of statements A and D is correct statements, and this is your option 3. Okay, in which option A and D present. Okay, statement A and D present. Okay, so option number 3 is the correct answer for this question, which contains statement A and D. Understand? Okay. Now we move towards our next question, and see, it says the spectroscopic ground state term symbols for the octahedral aqua complexes of these ions, that is manganese, chromium and copper respectively, are, and we have 4 options. Okay, so friends, you must find the spectroscopic ground state term symbol for these ions, for the aqua complex of these ions, octahedral aqua complexes of these ions. Okay, and this question is coming for 4 marks. That means it is also related to your part C. Okay, so let's do the solution of this question. Now first of all, what is the formula for finding the spectroscopic ground state term symbol? So the formula is 2s plus 1l. This is a general formula for finding the ground state term symbol, 2s plus 1l. Okay, now first of all, we talk about the manganese 2 plus complex, aqua complex of manganese 2 plus. So in the case of manganese 2 plus aqua, it is 3d5 high spin complex. See, it is 3d5 high spin complex. Okay, 3d5 high spin complex. High spin, why? Because it contains aqua ligand, which are weak field ligand. Okay, so 3d5 high spin complex means these, and the azimuthal quantum numbers of each orbital is plus 2, plus 1, 0, minus 1 and minus 2. So here the value of S is the sum of the total spins. Okay, sum of the spins of these all unpaired electrons. S is obtained by sum of the spins of all these electrons. Okay, so here 5 electrons are present, 5 unpaired electrons are present. So your value of S will be half plus half plus half plus half plus half, which is equals to 5 by 2. So the value of S is 5 by 2. So here the value of 2S plus 1 will be 2 into 5 by 2 plus 1, which is equals to 6. And how can we obtain L? So L is nothing but a summation of all azimuthal quantum numbers of the ligands. Okay, all azimuthal quantum numbers of the ligands. So when you sum the all azimuthal quantum numbers of the electrons, not ligands, sorry, electrons, then you will get the value of L. Okay, but here the terms associated with the value of L is, see, when you get the value of L is 0, that means it is related to your S term. L is 1 is related to your P term, L equals to 2 related to your D term, and L is equals to 3 related to your F term. Okay, and so on. Okay, so now in this complex, in the complex of manganese, the sum of all azimuthal quantum numbers are 0. See, this will be plus 3 and this will be minus 3. So plus 3 and minus 3 is equals to 0. So here the value of 2s plus 1 is 6 and the value of L is 0, which is leads to S term. So its ground state term symbol will be 6s. For manganese second, its ground state term symbol will be 6s. Okay, and similarly we also find the ground state term symbol for chromium 3 plus, and chromium 3 plus means it is 3d3 complex, and for 3d3 complex its ground state term symbol for is 4f, and for copper second it will be 3d9 high spin, and for 3d9 high spin its ground state term symbol will be 2d. Okay, you can follow this similar steps. Okay, and by following these steps you must find the ground state term symbol for this chromium and copper second ion also. Okay, so now the ground state term symbol for manganese second is 6s, for chromium third 4f, and for copper second 2d. So on the basis of this conclusion, your option number second is the correct answer. See in the corner friends, option number second is the correct answer for this question. Okay. Now we move towards our next question, and see it says, for OH negative catalyzed SN1 conjugate base mechanism of this complex, the species obtained in the first step of the reaction is or are, and we have 4 options. Okay, so here we have a reaction of this species or this substrate with OH minus catalyzed, and this is the SN1 conjugate base mechanism. This reaction follows SN1CD mechanism, and in this reaction you may find out the species obtained in the first step of this reaction. And this question is coming for 4 marks. That means this is also related to your part C. Okay. Okay, so let's do the solution of this question, friends. Now in the first step, there is an attack of the OH negative ion on your substrate species. And in the first step, one of the NH3 ligand can act as acid, because there is a replaceable hydrogen present in your substrate molecule. Okay, so there is a formation of conjugate base occurs in the first step. Okay, so now in the first step, this OH minus will attack on this substrate complex, and we get a conjugate base of this substrate, that is this complex. One hydrogen is released by one NH3 ligand. Okay, so this is a conjugate base. Okay, and this is a step first. Now after that, there is a removal of Cl ligand in this conjugate base. Removal of Cl negative ligand occurs, and this is a rate determining step of this reaction. Okay, so after that, after the removal of Cl minus ligand, we obtained a penta coordinated intermediate. We obtained this penta coordinated intermediate plus Cl. Okay, so this is a intermediate. This is a penta coordinated intermediate. Okay, and this intermediate will adopt TBP geometry. Why TBP geometry? Because NH3 is a pi donor ligand also, so it will stabilize this TBP geometry. We can discuss this point in the first question of this video. Okay, see, the first question is also related to this concept. Okay, so this will adopt the trigonal bipyramidal geometry, and after that the H2 will attack on this penta coordinated intermediate, and finally we obtain our product, that is this. Okay, so this product is obtained in this substitution reaction, and because in this reaction the substrate has a replaceable or acidic hydrogen, so this is followed by SN1CB mechanism. This is followed by SN1CB mechanism. Okay, so now, but in this question they may ask you about that what species obtained in your first step. So this conjugate base is obtained in your first step. Understand? Okay. This conjugate base is obtained in your first step. So the structure of this conjugate base is this. This species is obtained in your first step, and see in the corner this is related to your option second. Okay, so option second is the correct answer of this question. Understand friends? Okay. सो नाउ फ्रेंड्स, ये थे आपके कुछ क्वेश्चन जो CSIR नेट दिसंबर 2016 में कोऑर्डिनेशन केमिस्ट्री टॉपिक से पूछे गए थे. आई होप आपको अच्छे से समझ आए होंगे. फिर भी किसी भी तरह की डिफ़िकल्टी आती है तो कमेंट सेक्शन में आके ज़रूर पूछिए. ओके, सो थैंक यू फ्रेंड्स एंड थैंक यू फॉर वॉचिंग.